Hey everyone, Katrina here, and I'm going to show you how to find the arc of a circle. Be sure to subscribe for more videos like these and watch to the end to see our example. Okay, so this is a continuation of our discussion about radians. So we're going to introduce today how to find an arc of a circle, of a particular segment. So take a look at this circle over here. So the R here represents our radius. So this here is our radius of a circle, which again is half of its diameter. This theta over here in green, I'll write that again for you. This represents the angle between these two radii. Sorry. And then the new thing we're going to introduce today is the arc of the circle. So we're looking from this segment, I'm highlighting in yellow, from one segment of the radius to the other. And we're going to call that the arc. And we're going to represent that as A. So how can we actually determine what is this arc? Well, the formula is actually pretty simple. So in general, we have that the arc A is equal to the radius times theta, where theta, like you can see in this image, is the angle between the two specified radius segments. Okay, so how does this relate to radians? Well, radian has a special connection to this situation. Like if A equals to R, so if our arc is equal to our radius, then we have that theta equals to 1 radian. And that's how we come up with radians. So this is kind of a neat video because you can get the equation for an arc of a circle, but now you've also discovered this new derivation of what a radian actually is. Because sometimes it can feel a little bit arbitrary when we're going between degrees and radians, and you're like, okay, how did radians actually come about? And it's because of this really neat fact over here, that if your arc is equal to the length of your radius, that means that that angle between them has to be equal exactly to 1 radian. So that's a cool new fact that we learned today. So let's just do a little example to calculate the arc. So let's say that we have a radius that is equal to 5, and let's say that we have theta that's equal to 2 radians. So again, we don't have to write radians, we just can say 2, and then that's assumed that it is radian. So here we can just go ahead and apply the equation that we have, such that A equals to R theta. So in this case, our A is going to equal to 5 times 2, and that equals to 10. So in this case, we can see that our radius is not equal to our arc, and in fact our arc is twice the magnitude, or twice the size of our radius, and in fact instead of being our angle being 1 radian, we have that it is 2 radians. So we can see that relationship there as well. I hope you enjoyed this video and you learned some new facts about radians and arcs of circles. Please subscribe for more videos and definitely comment any questions that you have. I'll see you next time.